Now they ask me, calculate the root mean square current for the light bulb. So they want this. Now if I go to my data sheet, I can clearly find this one. Let us see what they've given us. They said here, an AC generator delivers 240 volts root mean square to a 60 watt light bulb. The peak current is 0.35 ampere. So they've given me the peak current. I want that maximum current. So that they've given me is 0.35 divided by the square root of 2, and you should get an answer of 0.25. What is my unit? I'm working with current, so it will be 0.25 amperes. Now they ask me, calculate the resistance of the light bulb. So I want to have R. Okay? If you go to your data sheet, you will see there's various ways in which you can calculate R. We have one where we have that R. Let's go to this one. It's written like this. P equals V square R. All right? Now, I must have here the root mean square value. I said earlier, we always work with the root mean square value for alternating current there. Now, if I look at my question, they've given me the root mean square. So I have that 240. And that I'm going to square. I want to calculate R. What is the power? They've given me the power. It will be a 60 watt. And now I will get the answer is equal to 960. And my unit for resistance is ohm. Guys, I hope that you can see it's a question of just knowing a couple of things. The one is that whenever I go to brightness, I'm working here with root mean square. That is my average value that I want to calculate. All right. There's another option. There was another option. I could have gone to Ohm's law. If I go to Ohm's law, then Ohm's law say that R equals V over I. Now it will be V root mean square over I root mean square. My V root mean square was given to me. There it is. 240. My I root mean square, I calculated it in 1.4.1, 0.25. And you will get the very same value of 960 ohms. More than one option. There was a third one. P equals I square R. Now, the P is 60. That I should be the root mean square value. And I've calculated that. So that should be 0.25, which I'm squaring. And then I get R. So when I simplify it, you will get the very same 960 ohm. So you could have chosen any one of these three options to do the answer. There were actually three ways of coming up with that last question's answer. So what is important? When I go to my power formulas or to Ohm's law, I need to have calculated the root mean square from the maximum value that they will provide. So they will either give to you the root mean square value or they will give you the peak value. And you can easily calculate the RMS value. All right. So that is an example there. Let us go through one more question. Let's have an example of an electric motor. All right, the essential components of a simplified DC motor are shown in a diagram below. All right, now they say to me, they tell me, this is a DC motor. Right, so I know that then this brush should be here connected to a cell, because electrical energy is provided in a DC motor. I also will know that because it's a DC motor, this will most probably what? That component will be a split ring, and that's correct. There they've given it to me. So if I have DC electricity that I provide, I will use a split ring commutator, and that will give me a DC motor. I'm providing direct current. When the motor is functioning, the coil rotates in a clockwise direction. You can easily read over things like this. So that's why I like to have a highlighter with me whenever I even do question papers. There is important information. When it's functioning, it is rotating in a clockwise direction. Now they want to know, write down the function of each of the following components. What is the function of a split ring commutator? Okay. Now we said that the commutator, it reverses the direction of current in the coil, or you can say armature, in the coil every half cycle, or you could say every 180 degrees of turning. All right, so that's what it's doing. We did look at it carefully earlier. Right, what is the purpose of the brushes? All right, the brushes is there to complete the circuit, to make sure there's electrical contact, to allow charges to flow in and out of the coil, anything that refers to a complete circuit. There's many possibilities. Due to space, I'm not going to write them down there. All right.